All right. So we're going to do another constant acceleration example now. So here's what's going on. We have cops and robbers. They're starting 60 meters apart. Okay. So the robbers are going to rob the bank. They're going to jump in their getaway car. They're going to accelerate to the right at 2 meters per second per second. 5 seconds later, the cops get the call, and then the cops are going to accelerate to the right at 5 meters per second per second. Okay? So we want to know when and where the cops catch the robbers. Okay? Now, let's do this problem according to the handout I distributed in class. Step 1, draw a clear sketch illustrating the problem. So we have the beginnings of our sketch here. We've got cops, robbers, we've got the bank. Okay, draw a coordinate system. All right, we got an x-axis. We'll put in our origin a little bit later. 3, identify and number the moments of interest. All right, so what would be our moments of interest for this problem? Well, we got the robbers jumping in their getaway car, right? So that would be the beginning of the process. Let's call that moment 0, and we'll indicate that as time t0 equals 0. Okay? The next moment of interest is going to be 5 seconds later when the cops give chase. Right? Now, we have 2 moving objects in this problem, and if we try to fit everything into one picture, things are going to get crowded. So we're going to have one picture for each moment of interest. Okay, so the next moment of interest and the next picture are going to depict when the cops give chase. So let's put in the next picture down here. X-axis. Okay. Now, at this point, the robbers have already been able to cover some ground. So when the cops begin to give chase, the robbers have already moved, but the cops are still at their starting position. Okay? Cops are still back here. Okay? So that's the next moment of interest. We'll call that time t1. Okay? And the final moment of interest, that's going to be when the cops catch the robbers somewhere over here. Right? Okay. Somewhere out here, the cops will catch the robbers. Okay? Okay? And this moment here where the cops catch the robbers, let's call that time 2. At that point. Okay? So we've identified and numbered the moments of interest. That's step 3 on your handout. All right, now we want to put in all the kinematic variables that we need. Right? So we already put in times for each of these moments of interest. Next, at each moment of interest, we want to put in symbols indicating position and velocity. And since we have 2 moving objects here, each of those is going to get its own symbols for position and velocity. Okay? So at time 0, the cops would be at x0 cops and have velocity v0 cops. The robbers would be at x0 robbers and have velocity v0 robbers. Okay? At time 1, the cops are at position x1 cops. The velocity is v1 cops. The robbers are at position x1 robbers. Velocity v1 robbers. Okay? Now, at this last moment of interest here, we don't need any velocities. right? And the cops and robbers are actually at the same position, but it will still be helpful to have one symbol for the position of the cops at this last moment of interest, and one symbol for the position of the robbers at this last moment of interest. Okay, so we'll put in x2 cops and x2 robbers. Okay? Now, finally, we need to indicate accelerations. Okay? And I'll make myself some room here by erasing the question. All right. Now, there's two accelerations here, right? One for the cops, one for the robbers. The robbers have the same acceleration all the way from moment 0 to moment 2. So to indicate that, let's just put in an arrow that goes all the way from 0 to 2 with the acceleration of the robbers. We have A robbers equals 2.00 meters per second squared. Okay? The cops only have their acceleration of 4 meters per second squared between moment 1 and moment 2. So let me put that, an arrow from moment 1 to moment 2 indicating the acceleration of the cops. We have A cops equals 4 meters per second squared here. Okay? All right, so we've defined all the kinematic variables, and as I went through and put in all the kinematic variables into the figure, I jumped the gun on some of these by putting in the values. But now we get to step 5, which is to go through and fill in what we know. Okay, and if you like, you can pause the video at this point and just fill in the rest on your own. Okay? All right, so proceeding. At time 0, the cops, let's say they're at the origin, position x0 cops, velocity v0 cops. Okay, the robbers are over here at position x0 robbers equals 60 meters. And this is just when they start to move. So v0 robbers would be 0. Okay? Okay, we come to time 1. This is when the cops are just starting, so their position and velocity are still 0. All right? Now, at time 1, the robbers have already moved, so we wouldn't know their position and velocity without doing calculations, so I'm just going to fill those in as question marks. Okay? We don't know the positions of the cops and robbers when they catch each other. We'll leave this blank here. And the only other thing that we've been given is the time when the cops begin to chase the robbers, which would be 5 seconds. And we don't know the time where the cops catch the robbers. Okay, so this is a complete diagram showing what we know. All right? Okay, now, as far as solving the problem, here's what we know, right? At the moment the cops catch the robbers, the positions are equal, right? In other words, at the moment the cops catch the robbers, we can say x2 cops equals x2 robbers, right? Okay. I didn't make good use of space. So, hope you got that in your notes. Here's the idea. We have x2 cops equals x2 robbers, right? That's how we know the cops catch the robbers, that the positions are equal. So how can we use that to solve the problem? Well, here's the idea, right? We know that the time when the cops catch the robbers is time 2. We defined it as such. So how about we we express the final position of the cops in terms of the final time, t2. Express the final position of the robbers in terms of the final time, t2. In other words, what we're going to do here is we're going to get x2 cops in terms of the final time. We're going to get x2 robbers in terms of the final time. Once we have both of these final positions in terms of the final time, we can equate those expressions and solve for the final time, and that will then allow us to figure out where the cops and the robbers met each other. Okay? All right, so we want to get positions in terms of time. Okay? Now, we have two constant acceleration processes here, one for the cops, one for the robbers, and for a constant acceleration process, we'd like to get position in terms of time. So, which of these seems appropriate? Well, how about number 3, right? Number 3 gives a position at the end of some process in terms of the elapsed time for the process, right? You might also look at number 5 and say, oh, here you have position in terms of time, but then you need the final velocity. So equation 3 is going to be what we use here. We're going to take equation 3 and we'll apply it to the robbers and we'll apply it to the cops. Okay? First, let's apply this to the robbers. Okay? The robbers have a constant acceleration all the way from moment 0 to moment 2. So we just have to take this and apply it to the robbers and change the 1 subscript to 2. Okay? So, there we go. Actually, I'm going to just copy that here. So we have x1 equals x0 plus v0 delta t plus 1/2 a delta t squared. Okay? All right, now, applying this for the robbers. Applying this for the robbers. Robbers have constant acceleration all the way from moment 0 to moment 2. So that 1 subscript is just going to become 2, and we'll put in r subscript for robbers where we need it. So that's going to give us x2 robbers equals x0 robbers plus v0 robbers delta t plus 1/2 a robbers delta t squared. Okay? Right. Now, the other thing we're going to do here, since the robbers have constant acceleration from 0 to 2, and we're using this equation here to connect moment 0 to moment 2, delta t is just going to become t2 minus t0. Okay, so we have delta t equals t2 minus t0. All right. Now, we can make some simplifications here, right? V0 robbers is 0. T0 is 0. Okay? And when we put this all together, we'll just change this delta t over here to t2. And we get x2 robbers equals x0 robbers plus 1/2 a robbers t2 squared. Okay, so that's the first part of this, where we get the final position of the robbers in terms of the final time. Now we've done that. Now the next thing is to get the final position of the cops in terms of the final time. Okay? All right, so my apologies, I'm going to just have to erase the figure here so I have some room to work. You have that in your notes, hopefully, or you can go back earlier in the video if you need it. My apologies. Okay. Now we'd like to get the final position of the cops in terms of the final time. Okay? So again, we're going to use our equation that gives position as a function of time for constant acceleration. Now the cops only have a constant acceleration from 1 to 2. So the zeros are going to become 1s. The 1s are going to become 2s. We'll put in a C subscript for cops where we need it. So we have x2 cops equals x1 cops plus v1 cops delta t plus 1/2 a cops delta t squared. Okay? All right. Now, the cops only have their constant acceleration from time 1 to time 2, right? So delta t here represents the time interval from time 1 to time 2. So we would write delta t equals t2 minus t1. Right? Now we also have that x1 cops is 0 and v1 cops is 0. So making the substitution for delta t here, we have x2 cops equals 1/2 a cops t2 minus t1 squared. Okay? Right? So we're moving along with our strategy here, right? Because we got an expression for the final position of the robbers in terms of the final time. We got an expression for the final position of the cops in terms of the final time, right? Now, we know that the final time for both cops and robbers is where the cops catch up to the robbers. In other words, the final time for both cops and robbers is where x2 robbers and x2 cops equal, right? Okay, so what we can do is we can set x2 cops equals x2 robbers, set these expressions equal to each other, and see if we can solve for the final time. All right, so continuing over here, set x2 cops equals x2 robbers. Okay, substituting, we have 1/2 a cops, t2 minus t1, quantity squared, equals x0 robbers plus 1/2 a robbers t2 squared. All right, so we want to isolate t2 somehow. Well, let's just put everything on one side of the equation and see if that rings any bells. Okay. Okay. All right, let's expand out the binomial here. So we'll have 1/2 a cops t2 squared minus a cops t1 times t2 plus 1/2 a cops t1 squared plus, minus x0 robbers minus 1/2 a robbers t2 squared. Okay. Again, I'm not used to this compression of space. Didn't all quite fit on one line, but there we go. We have all of these terms all on one side equals 0. And how are we going to isolate the t2? Let's see. T2 squared. We have a t2 squared here. Here we have a term with just a t2. And then here's a couple of terms that don't have any t2s in them. And then here's another t2 squared. And everything else is known, so I guess we need a quadratic formula here, right? Okay, so we're going to proceed to use the quadratic formula. We're going to group quadratic terms, linear terms, and constant terms. Thus, you have 0 equals, all right, 1/2 quantity a cops minus a robbers, t2 squared. 0 equals 1/2 quantity A cops minus A robbers, T2 squared. Okay, that's our quadratic term. Minus A cops T1 times T2. And then plus 1/2 A cops T1 squared minus X0 robbers. Okay, so now we have this in standard quadratic form. This would be our quadratic coefficient, right? Our linear coefficient. And then there's our constant term. Okay? So this is an exercise for you to do. You can pause the video, make all the substitutions here, plug into the quadratic formula, see what you get. I'll just outline how this is going to go. Okay? So A turns out to be 1 meter per second squared. B minus 20 meters per second. C minus 10 meters. Okay, now substitution of this into the quadratic formula. Again, this is something where you can pause the video and try it on your own, but substitution into the quadratic formula is going to give you a negative root for time 2 and a positive root for time 2. Of course, we want the cops and the robbers to meet each other at a positive time. So we'll take the positive root, which is time 2 equals 20.5 seconds. Okay? Now, once we find that the cops and robbers meet at time 20.5 seconds, we can take either the equation for the final position of the cops or the equation for the final position of the robbers, substitute the final time, and then that gives the final position for both of them. Okay? So I use the equation for the final position of the cops. So we'll then say x2 cops equals 1/2 A cops T2 minus T1, then squared, and then on substitution, 480 meters. Okay, there you go.